Welcome to Physical Sciences Consultorium. This video is part of the series How We Know the Universe. In this series, we explore how scientists make sense of the universe using surprisingly limited information. When we look at the night sky, it feels as if we are directly seeing the universe. But that feeling is misleading. We are not touching stars. We are not visiting galaxies. We are not collecting samples. For almost everything we know about the distant universe beyond Earth, our primary source of information is light. This raises a natural question. If light is all we have, how can it possibly be enough? To answer this, it helps to think of light not as illumination, but as a courier. A courier that carries messages from distant objects to us. But like any courier, light passes through stages, and each stage leaves its mark on the message. The first stage is emission. Stars and galaxies do not emit light randomly. Light is produced because matter behaves in specific physical ways. When matter becomes hot, it glows. When atoms rearrange their internal structure, they emit light at very specific energies. These processes are governed by physical laws, not choice. This means that the light leaving an object already carries information about what that object is like. The second stage is travel. Light does not arrive instantly. It travels across space for years, centuries, or even billions of years. Along the way, it can be stretched, absorbed, or scattered. At first, this sounds like bad news. Information seems to be lost. But crucially, these changes do not happen randomly. Each type of change follows rules. Because the rules are known, scientists can account for their effects. The third stage is detection. Telescopes do not simply take pictures. They measure how much light arrives, at what colors, and how those properties change over time. These measurements are imperfect and noisy, but they are not meaningless. When different measurements agree with one another, confidence grows. This is how astronomy works. Scientists do not extract certainty from light. They extract constraints. Light rules out what cannot be true and narrows down what remains possible. For example, if a star appears faint, it must either be weak or far away. Other measurements help decide which. If a galaxy's light shows certain patterns, it must contain specific elements. Other patterns must agree. Astronomy advances by checking whether many pieces of light-based evidence tell a consistent story. There is one important assumption behind all of this, that the laws of physics are the same everywhere. Hydrogen in distant stars behaves the same way it does on Earth. This assumption is constantly tested. If it failed, astronomy would quickly fall apart. The reason it survives is that independent observations keep confirming it. So what does it mean to know something in astronomy? It does not mean absolute certainty. It means that after accounting for how light is produced, altered, and detected, only a narrow range of explanations remains physically possible. Light becomes information not because it tells us everything, but because physics limits what it can be. Those limits are what scientists use. We do not know the universe by touching it. We know it by carefully reading the only messages it sends us. If this way of thinking about space science interests you, this is exactly what Physical Sciences Consultorium exists for. PSC explores science as a way of understanding reality, not as a syllabus and not as trivia. If you enjoyed this video, you may like, share, and subscribe to support this outreach effort.